C1, Exponentials and Logarithms, example 17. So this example is slightly different to the exam questions you've done previously in this booklet. It does relate to geometric progressions, which is a certain type of sequence you have at C2. However, you'll be able to answer this question as it's relating to some of the techniques you've learned in this booklet. So for part A, we need to sketch the graph. It's an exponential graph, which you will be familiar with, that take this sort of shape, where we've got an asymptote along the x-axis and y is increasing exponentially. However, when you're drawing this graph, we want to start x from 0, as x is talking about the number of years. So we're investing some money into a savings scheme and we want to work out how much money we've got after each year when we've got an interest rate of 4%. So we're not going to have any negative values of x. So you need to get the general shape of the graph. And we also need to mark on where it crosses the y-axis. So our equation is 1.04 to the power x. And when x is 0, 1.04 to the power 0 is just equal 1 to 1. So we know that on the y-axis the graph starts out at 1. So with it being worth 2 marks, they'll be looking for you to label the y-axis and get the general shape of the graph, but with no negative x values. For part B, we want to work out how much money we've got after 10 years after initially investing £800 into the scheme. So we need to change the equation slightly to this form, where A is our initial investment. So we're not just starting out at 0, we're actually putting £800 into the scheme at the start, so A is 800. And we want to work out how much money we've got after 10 years, so x is 10. So you can work that out on your calculator. 800 multiplied by 1.04 to the power 10, which gives you 1184.195. But we want to give our answer to the nearest pound. So our answer would be £1,184. That's how much money we'd have after 10 years, after initially investing £800. On part C, we need to use logarithms. So we've got our equation and we want to work out how long it takes us to double the value of any initial investment. So if we're starting out with A, and in this example in part B we had A was 800, we'd be wanting to work out, well, how long does it take, so we'd want to work out x, how long does it take for us to get £1,600? So in this case, a general equation, we'd be wanting to work out, well, how long does it take A to double? So how long does it take us to have 2A? So if A was £500, how long would it take us to have £1,000 in our account? So if we divide both sides by A, we get 2 equals 1.04 to the power x. If you were solving it this way, you'd get exactly the same thing. Divide both sides by 800, get 2 equals 1.04 to the power x. So we now need to solve an equation with powers, so we need to log both sides. So if we log both sides, that then enables us to bring that x to the front. And we want to find out x, so we need to divide both sides by log 1.04. And we can work that out on our calculator. Log 2 divided by log 1.04. That gives us 17.67. So after 17 years it wouldn't quite have doubled, so we need to round up. So it's going to take 18 years for us to double any initial value that we put into into the savings scheme.